What I want to do here is go through this investigation, multiply and conquer, just looking a little bit at some simple proportions and how we can solve them. Okay, so the first step is they say to multiply both sides of this proportion, which remember is a ratio equaling a ratio, by 19. So I'm going to do that. And one thing that I really think is valuable with fractions is instead of multiplying by 19, I mean, we're doing the same thing, but multiply by 19 over 1. Because 19 over 1 is a fraction, and then it's just a little bit easier to remember that when you multiply two fractions, you multiply straight across. So numerator times numerator and denominator times denominator. And then this would be equal to 56, divided by 133 times 19 over 1. So why can we do this? Well, we have an equation, it's balanced, right? So like if 2 equals 2, that's a balanced equation. And if we multiply both sides by 19, we'd get, say, 38 times 38, or 38 equals 38, which is still balanced. So we can always multiply both sides of an equation by the same non-zero number. So I'll add a little text box here. So that's really why we can do this, because it ensures that the equation remains balanced. So if we simplify both sides here, we'll do 19 times m and 1 times 19, and that should give me 19m over 19 is equal to 56 times 19. I think I could do that in my head. It's like 560 times 2 divided by, or minus 56, which is like, maybe like 1064. Yep, 1064. That's 56 times 19. And then I'm going to divide it by 133 times 1. I'm multiplying straight across. So of course 19 divided by 19 is 1, so that just gives me m. And over here I get 1064 divided by 133, and that is 8. So we end up with m equals 8. Okay. So moving on to step 2. For each equation, choose a number to multiply both ratios by to solve the proportion for the unknown number. So back here, again, when we had m divided by 19, we multiplied by 19 because then we undo that division with the multiplication. So that's really what we want to do over here as well, is look at what the variable is divided by, and then and then multiply by that number. So for a, we have p over 12 is equal to 132 divided by 176. And so what I see is that p is divided by 12, so to undo that division and get p alone so that we know exactly what p is, I can multiply by 12 over 1, or 12, on both sides. And you'll notice I'm using a little dot for multiplication. Let's add a sticky note in here. Use a dot for multiplication as we use x's, for variables now. So we really don't want to have 2 times 3. Instead, write 2 times 3. I can't really write a dot there, but you get the idea. 2 times 3 is sometimes how we write it. Okay, so a little sticky note that we'll just save over here on the side. Okay, so continuing on here, we're going to get p on this side is equal to then 132 times 12 which is going to be 1,584, and then we'll divide it by 176 to get 9. So p equals 9. Now, for step 3, it says check that each proportion in step 2 is true by replacing the variable with your answer. So to check this, we are going to plug it back in. So we solved the proportion, but now we're going to plug it back in. So if I plug 9 into the original equation, I get 9 over 12 is equal to, with a question mark because I'm checking my answer, 132 over 176. So let's find the decimals and see if they are equal. So 9 divided by 12 is 0.75, and 132 divided by 176 is also 0.75. So since 0.75 is equal to 0.75, I can put a check there, and I know that my answer is true. Okay, let me do one more with you, and then I'll ask you to do the last two. So for B, we have 21 over 35 is equal to Q over 20. And so since Q is divided by 20, I want to multiply by 20 to undo that division. So I'll multiply by 20 over 1 on both sides. Here I'm going to get 20 times 21, which is 420, divided by 35 times 1 is equal to Q, because again, if I have a 20 in the numerator and a 20 in the denominator, 20 divided by 20 is 1. So I just get Q, because it would be 20Q over 20, and that's just 1Q. So 420 divided by 35 is 12, so I get 12 is equal to Q. So to check my answer, I can plug that back in, and I can get 21 over 35 is equal to, question mark, 12 over 20. And so let's see, this means that, let's see here, 21 over 35 is 0.6 equals 12 divided by 20, which is also 0.6. So yep, I got the right solution. So you can follow a similar process for C and D. For step 4, we have the question, in each equation in step 2, the variables are in the numerator. Write a brief explanation of one way to solve a proportion when one of the numerators is a variable. So coming back here to these, we can see that we've got variable, 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 and what I'm noticing is that we multiplied both sides of the proportion by the number that the variable is divided by. So since P is divided by 12, we multiplied both sides by 12. Since Q is divided by 20, we multiplied both sides by 20. And I think it's nice to multiply by 12 over 1 and 20 over 1. It just helps me be a little bit clearer with my mathematics. So let's add a text box here and say, well, if you have a, and let's make this bigger so it doesn't wrap so quickly. How about that? How do I make this bigger? Not like that. I think it'll get bigger as I type. Well, if you have a proportion with one of the numerators as a variable, to solve, multiply both sides of the equation by the number which the variable is being divided by. For instance, if you have x over 15, multiply both sides by 15 over 1. Great. So for step 5, it says the proportions have been changed by switching the numerators and denominators. So we took our proportion and we flipped them, okay? The ratio on each side has been inverted. It says you may recall that inverted fractions, like p over 12 and 12 over p, are called reciprocals. Do the solutions from step 2 also make these new proportions true? So we took the step 2 proportions and we just flipped them. And now we're curious, would the solutions that we got earlier still be the same? So let's go back and still work. And look at our solution to A, which was 9, and look at our solution to B, which was 12. So if we flip these proportions, will those solutions still work, is the question. So let's check. So for A, we would have 12 over 9. Is it equal to 176 divided by 132? So let's see. Well, 12 divided by 9 is 1.33. Repeating. And is that equal to 176 divided by 132, which is also 1.3. Repeating. So yes, it works for A. For B, our answer was 12, so is 35 over 21. We're looking at this guy right here. We're looking at this one right here. That's the one that's being written down here. Is it equal to 20 over Q? But Q we got 12. So let's see if these are equal ratios. 35 divided by 21 is 1.6, repeating. Is it equal to 20 divided by 12, which is also 1.6, repeating? And the answer is yes. So it appears that this works. And of course, I would like you to follow a similar process for C and D. Okay, so it looks like if you take two proportions, or one proportion, which is a ratio equaling a ratio, and you flip both sides, you still get the same solution. Step 6. How can you use what you just discovered to help you solve a proportion that has a variable in the denominator, such as 20 over 135 equals 12 over k? Why does this work? So you'll notice the difference in this equation is that for the ones we saw, the variable is in the numerator every single time, and we decided that if the variable is in the numerator, you can simply multiply both sides of the equation by the number which the variable is being divided by. So for instance, if you have x over 15, multiply both sides by 15 over 1. Then we saw that if you flip the proportions, you invert them, you still get the same solution. So since we have a variable in the denominator here, maybe we could invert it and then solve it from there. So my suggestion is going to be, let's invert the proportion to get the variable in the numerator. Then we may multiply both sides by the number that the variable is being divided by. Okay? So that's what we're going to do. So let's take this proportion and let's invert it. So 20 over 135 is equal to 12 over k. Let's invert it. And let's get 135 over 20. So we just flipped that ratio, is equal to k over 12. Now we know we can multiply both sides by 12 over 1 to solve for our variable. And so that should tell us that 12 times 135 divided by 20. But one thing I'll mention is that if you have 12 and you have 20, you could simplify these and divide them both by 2. So we could make this 6 and this 10. That simplifies a little bit. We could also make this now 3 and this 5. So we're just simplifying by dividing both of those numbers by the same thing. And here we could just cancel them out because 12 divided by 12 is 1. So now what we actually have is 3 times 135 over 1 times 5 is equal to k. And that means that k is equal to, well, let's see, 81. Okay, so we'll do our fancy dancy laser right here, and that's our solution for that proportion. Okay, so That was fun. I think this one's just blank, so that's the end of this video. Hope that was helpful, and I'll see you soon.